I am looking out over this beautiful landscape that is covered in snow. I realized that it won't always be that way for the rest of my lifetime. And I felt sad because this is a landscape that is an integral part of the Earth. Life as an Earth scientist means understanding the planet that we live on, and especially in the context of climate change, understanding where that planet is headed. So for a glaciologist, that means understanding where ice is headed. I try to understand how glaciers in Greenland and Antarctica flow, how they have changed in the past, how they're changing presently, and how they will change in the future. That ice flow can vary over time and can have significant consequences for the Earth systems around it, and hence also societies that are dependent on either the water that those glaciers release or the sea levels that those glaciers can influence. When you are flying over these polar regions, it's an alien world. And when you're standing on the ice in these regions, it can also feel incredibly desolate, but also liberating at the same time. The biggest scientific question that I'm pursuing right now is what is going to happen to these two remaining large ice sheets in Greenland and Antarctica in the coming centuries. Are they going to retreat dramatically? Are they going to collapse? Or are they going to be relatively unaffected by a changing climate? That's the question. On board IceBridge airplanes, we have a laser that can very precisely measure the elevation of the surface. That allows us to monitor the health of glaciers and ice sheets. We have ice-penetrating radars that send out radio frequency pulses and reflect off of layers within the ice. From that, we can learn about the structure of the ice below us, how thick the ice is, and about the properties of the rock below. It takes a large concerted effort like Operation IceBridge to go out there and not only make the repeat measurements that we need to understand changing ice, but to go out and learn new things requires a steady focus on the act of exploration. NASA, in my view, seeks to do things both technologically and scientifically that have never been done before. We're learning something about the ice and the rock and the Earth system in these places that no one ever knew before. And so you really feel like not only do you have the potential to leave your mark as a scientist, but you're contributing to the greater good. We don't know if we can stop the changes that we've seen, but what I do know is that if we can, it will require us to learn a lot more about what is going on in the polar regions and to go out there, boots on the ground, explore what's going on as scientists.
Coral reefs, they're sometimes dubbed the rainforests of the sea, and I think that's true. They actually house a quarter of all the oceanic fish species. The Coral Reef Airborne Laboratory, otherwise called the Coral Mission, is a 3-year investigation to use state-of-the-art airborne as well as in-water measurements. We're looking at a portion of the world's reef system to assess the condition of these threatened ecosystems and relate how they're changing to their environment. The instrument that flies aboard the aircraft is observing light that's reflected from the ocean's surface. What the instrument is actually able to do is break down that light into profiles. So just like you or I have unique fingerprints, the instrument is actually able to discriminate the different sort of unique fingerprints of coral algae in the sand. We have an in-water team to validate what we're seeing from the instrument itself. Our current understanding of coral reefs is really only about 0.01 to 1% of reefs worldwide. That's extremely small. We know they're threatened, but do we really understand how that all works together, how their condition changes with respect to their environment of global climate change? That's really what we're trying to do for coral, providing this unique data set and then looking at those different conditions. How is it changing with respect to increasing ocean acidification, increasing ocean temperatures? I am a soon-to-be parent. I want to provide my child with an Earth system that I grew up with, that I know, that I love, that isn't so dramatically different, that certain species and certain ecosystems are no longer there, and that it's viable for life. It's great when you find what you expected, but I love when what I assumed is not what I find. That's what drove me to science, just the intrigue of it, the mystery. It's what keeps me going.
There are thousands of scientists at NASA, at JPL, and other institutions around the globe who have dedicated their careers to better understanding the Earth as it is and developing models that can help us project what the future of the Earth is. That is a personal commitment from each of those scientists that you can't easily walk away from. When you are a scientist, you want to understand the world as it is, not the world as you wish it were.
Though I'm an oceanographer, clearly the ocean, the atmosphere, the land, the cryosphere, we're all connected as an Earth system. We're all impacting one another. We really need to have a better understanding of that inner working.
NASA continually wants to move forward not only our understanding of Earth, but of course the Moon, the solar system, worlds beyond that. We want to learn the new things, and I'm very glad to be a part of that.